Hi, I'm Megha Manjanith, and I'm a senior in biological engineering, and our group is the Exploring Healthier Alternatives to Snacking, Exploring Vegetable Chips.
My name is Shristi Sharma, and I'm also a biological engineering student.
My name is Zijan Wong, and I'm also the same thing.
So first, we start with the reasoning for our product. We wanted to bring in a new quality product to the snacking business, and that was potato chips. But not just potato chips, we wanted to explore vegetable chips, zucchinis, tomatoes, and all other kinds of vegetables. So everything that we have here is just kind of the intro to that. We know that commercially, this is a huge product. It's booming, and potato chips are the thing now, so we wanted to market this to college students who wanted to snack and things like that.
As Megha had mentioned, right now, it's all about being healthy, so our product is geared towards the product of healthy people, healthy chips. So for materials and method, we had 6 steps. We had peeling, slicing and washing, blanching, drying, cooking, sterilization, and seasoning. So here we have the optimized steps to each of the unit operations, as well as our flavor ingredients at the bottom. We also have the sustainability and optimization here, where we had optimized 3 unit operations, which are blanching, frying, and drying. As you can see here in figure 6, this is the continuous loop blanching system, which is using recycled water all the way from the slicing and washing process to blanching. So it's a great looping operation. And then as for frying, there is the reutilization of the frying oil material, and 3, the heat pump is used for the drying.
Okay, so from our preliminary results, we're supposed to get rid of oil. That's the number one thing you want to get rid of if you're talking about healthy. And from our experimental results, we showed that the higher your frying temperature, the less time you need to go ahead and get the thing to be edible. But the problem with that is, if you have too high of a temperature, your potato will just go completely black, and nobody's going to eat that. So from experimental results, we have decided that 350 was definitely way too high of a temperature Fahrenheit. So more optimally, we'll like to go with like a 300 degree Fahrenheit, but also we don't want to spend too much energy in like putting the oil for like 10 to 15 minutes. We don't want to do that. So 300 degree Fahrenheit, 2 minutes, 1 to 2 minutes will be perfect. And then we're going to follow up the frying stage with drying. So we don't do the multiple stage of frying. So in that case, we can get rid of even more oil, and that will be even more healthy for our customers. And we also show in these graphs, these don't kind of make any sense from our experimental data, but you can see that for your 325 and 300 degrees, you're basically leveling off to the same crunchiness. This is crunchiness. Think of that as a measure. And from our economic point of view, we have decided, we don't have it here, but we have a table that basically we use to calculate how much annual cost and how many bags of potato chips we're going to manufacture yearly. And since we're looking at a relatively small market, we're only going to manufacture around 550,000 bags of potato chips a year, and then that's going to be targeting students from around Purdue University primarily. And then if you kind of look at our estimated total product cost, that is ranging from around $540,000 to as much as $4 million if you go with the more higher end equipment and other stuff. So optimization of cost is really going to be a big part of our project when it's actually out there, and we can definitely make a profit as long as we sell more than $1. We can make a profit just from the rough estimate.
I think the main objective of our entire project was to optimize and not have a lot of waste in our operations, which you can see in the peeling that we're leaving our potatoes unpeeled, not only to not have any waste in our overall process, but to also make our chip healthy. And as I mentioned earlier about the blanching system, it's continuously looped, so there's recycling of the water.
And so for our future direction, we're taking this to the large-scale production. We'll incorporate the heat pump drying system, and also the things that Shrishti mentioned, the recycling of the water and the other waste materials that we have. And so with that, we'd like to thank Purdue Agricultural and Biological Engineering Department and also Professor Okos.